Hello, everyone. Today, I'm going to teach you how to use the circle theorems effectively when solving problem. Because there might be problems where you're not going to apply just one of the theorems. You might apply two or more theorems. So it's important to follow some strategies, to follow some guidelines in order to be able to work them out independently and with confidence. So I would advise you, in the early stages of working with circle theorems, you have a printout worksheet with all the theorems. So whenever you deal with problem solving, you have it on the other side, and you kind of go parallel with which theorem you can apply. And the more you do this one, the more confident you become. So you're not going to need the printout worksheet at all in the later stages of working with circle theorems. So here's a question. Here we need to find out the size of angle A. So this is the picture you have, and have a look on the right-hand side. These are the 5 theorems I taught you in the previous lesson. So which of them we can apply? So let's take them one by one. Can I apply this one? No, because I'm not dealing with the angles at the center of the circle. There we go. So not this one, definitely not this one, you can see. And there's no tangent, definitely not this one. I'm not dealing with any cyclic quadrilaterals, so definitely not this one. So put a cross out. So this is the theorem I'm going to use. Okay, I can see the angle that is formed in a semicircle, and I can see the diameter right there. Right. So, and that means that this angle HJG. HJG. Actually, I'm going to relabel the angle. This one here is going to be 90 degrees. I'm going to relabel this as a capital J. Okay, and I'm going to relabel this one again as a capital H. So I'm not going to use a 3-lettered angles just to make it easier for you. In this one here, G, angle G. There you go. So angle J, write it down, okay? Angle J equals 90 degrees. And this is from the theorem. You must use the theorem. So there you go. In brackets here, in brackets, write down the angles. You don't have to write the whole theorem. So okay, in a semi, just like that, is, okay, 90 degrees, just like that, all right? So this one is 90 degrees. Can we find angle H? Of course we can. Triangle GHJ is a right angle triangle. So we are going to have angle H, okay, plus 35 degrees, which is angle G. I'm going to do this straight away. Plus 90 equals 180. And this is from interior angles in a triangle, right? The sine of the triangle is 180 degrees. Just like that. Close the bracket. Okay, make it, reasoning is key when you solve problems in geometry. So there you go. So angle H here. So angle H, this is going to be, so 35 plus 95 is 125 to 180, 25. So it's going to be 55 degrees, okay? Angle H is 55 degrees. And you can, of course, label the angle right here. It just makes it a lot easier. Okay, but now we need the angle A here. We know angle H is 55 degrees. What else do we know? Have a look at this side. OH and OJ. What are they? I'm going to do a little line here. Okay? And this means OH equals OJ. OH equals OJ. Because as radiuses, they are radiuses. Okay? So write it down. And that means, just write, so triangle HOJ is what type of triangle? Isosceles. Okay, and close the bracket. Okay, and that means angle H equals angle A, see, equals 55 degrees. Huh? As angles, okay, at the base of an isosceles triangle. Just like that. So that angle here, it is equal 55 degrees. Right, let's have a look at another question. You see how important is the reasoning? So writing down the reasoning, the reasons, every step, why a certain angle or a certain side is equal, or how much there is. Okay, next one here. Again, if you have a look at the right-hand side, you can see again, but as I said, the more you do, you're not going to need this printout worksheet at all, because you're going to learn the theorems by heart. So this is one you're going to use again. That means, again, this angle here is a 90-degree angle from exactly the same theorem. From this theorem, the angle formed in a semicircle is always a right angle. And this is 20 degrees. That means this angle here is going to be 20 degrees because the sides are equal, and triangle POQ is an isosceles triangle. That means NOP is an isosceles triangle, right? So if you know this one is 20, then this angle A here is going to be 70 degrees. That means this angle here is going to be 70 degrees. So just like that. Now, it is your turn to write down the solution and the reasoning of what I said, following the steps. And here is another question for you, which you can work independently. So let's have a look at what theorem you can apply. Yeah, straight away you can tell, is this theorem here, we're not going to use this one, or this one, or this one, or this one. So that means this angle here, so angle A, A equals 40 degrees, okay? So write down the theorems, angles from the same arc. Angles from the same arc in the same segment, okay? Okay, are equal. Okay, there you go. So this angle here is 40 degrees. And of course, angle B equals 20 degrees for the same reasons. Again, angle from same arc theorem. Just like that, and full stop, just like that. And so again, what you're getting from this lesson is in the first stages of learning how to apply circle theorems, have a printout worksheet with all the theorems in there, and compare what you have in a problem with what it is in the theorem, in all the theorems. Now, if you can identify straight away without even looking at the theorems, well done to you if you remember all the theorems one by one, okay? But if not, then work just like this. So compare the theorems with the problem that you have, and don't forget to write the reasoning for every step you do. So thank you very much for watching my steps, and have a lovely day. Well done. Bye-bye.